We see? We can. Right. So I'm going to look at page 51E first. So we have tan pi over 2 minus x. That's equal to tan A minus tan B all over 1 plus tan A tan B, which in this case is tan pi over 2 minus tan x all over 1 plus tan pi over 2 times tan x.
Tan pi over 2 is infinite.
Correct. Tan pi over 2 is infinite. So the way we deal with that is we divide everything by tan pi over 2. So we got 1 minus tan x over tan pi over 2 all over 1 over tan pi over 2 plus tan x. And what we have here is tan pi over 2 is infinite, but 1 over tan pi over 2 is 0. So this will become 1 minus 0 over 0 plus tan x, which equals 1 over tan x, which equals cotan x. Oh, the board just needs to be moved. Another way of writing this here, 1 over tan pi over 2 equals 0, is here we could have said cotan pi over 2 is 0. It's another way of looking at it. Okay. We have that? Yep. Okay. Can I scroll down now? Yep. So what we're going to look at now on page 52, we're going to look at, we're going to go back to integration for a moment. So what we're going to do is use our rules of trigonometry for integration. Come on. So for example, we want to integrate 4 cos squared 2x dx. So in this lesson, there'll be one new formula which I'll show you in a moment, but most of it is done by substitution. So for example here, if I want to do a problem like this, I can change it into 4 cos 2x dx. Then I need to use my compound angle formula. Cos A minus B is cos A cos B plus sine A sine B, and cos A plus B is cos A cos B minus sine A sine B. If I add these together, I get cos A minus B plus cos A plus B equals 2 cos A cos B. If I multiply both sides by 2, I get 2 cos A minus cos B plus 2 cos A plus B equals 4 cos A cos B. Then on the next line I make A equal B equal 2x. So this would be 2 cos 0 plus 2 cos 4x equals 4 cos 2x cos 2x, which you can see is exactly the same as what I have back in the question here. I have a cos 2x, a cos 2x, and a 4. Cos 2x, cos 2x, and a 4. So I can replace it with this. And by the way, cos 0 is 1. So this is 2 plus 2 cos 4x. So back to the question here. This equals integrate 2 plus 2 cos 4x dx. And now that's actually easy to integrate because this here will be 2x. This here will be plus 2 sine 4x over 4 plus c. So this one is 2x plus a half sine 4x plus c. So that would be the answer. Okay, can I go down? Yeah. Okay, so for the next question, we have to use a new rule. So I'll show you what the new rule is. So for a moment, let's try and calculate the derivative of sine inverse x, which we know how to do if we use implicit derivatives. So what I do first is I put a sign on both sides. Then I differentiate. This is cos y dy dx equals 1. So dy dx equals 1 over cos y. Now I can draw the triangle here. This has opposite of 1. Opposite of x, hypotenuse of 1, and adjacent of root 1 minus x squared. And this is y. So you can see from here that cos y is root 1 minus x squared. So this is 1 over root 1 minus x squared. So what you have is the derivative of sine inverse x is 1 over square root 1 minus x squared. Very similar to what we did when we did tan inverse. Derivative of tan inverse was 1 over 1 plus x squared. But what's useful here is I can integrate both sides. So you get this rule, which is the rule I want for today. Sine inverse x equals integrate 1 over root 1 minus x squared dx. I'll just write that again a bit neater, sorry. So sine inverse x plus c, of course, that's equal to integration of 1 over root 1 minus x squared dx. So that's our new rule for today. I'll show you how to use that now for these questions.
Will they have to prove it from the exam?
I've seen it asked before, yes.
I mean, if you look at a question like this, will they have to prove the answer for me?
No, you can use the formula directly, but I have seen them ask you to prove it before, yeah. In fact, last year is when they asked it. It'll either be, it's been sine inverse and tan inverse.
What's tan inverse?
1 over 1 plus x squared. Okay, can I go down? Yep. So let's have a look at some examples. So suppose you want to calculate this 1 over, 1 over square root 16 minus x squared dx. Now if you look at your formula, it's nearly the same, but it's not quite. The problem is we have a 16 here, and we really need a 1. But we can fix that with a substitution. What we can do is, we can say, let u equal x over 4. And we've kind of seen something like this before, where you let u equal to the square root of this divided by square root this. We've seen that before. So with that we can say 4u equals x if you want, and you can also say du dx equals a quarter. So you could say 4 du equals dx. This one here is useful, this one here will be useful, and this one here will be useful. So if I go back to the question, this is 1 over square root 16 minus 4u squared, and dx is 4 du. So this is 4 du over square root 16 minus 16u squared, which is du with a 4, and then 16, 1 minus u squared, which is 4 du, and I can take that root 16 out in front, root 1 minus u squared. Now what's nice here is root 16 is 4, so in fact this will cancel with this, and you're left with du over root 1 minus u squared. Now we can use our formula. This is equal to sine inverse u plus c. So that's sine inverse x over 4 plus c. Can I go down? Yeah, do another example. Okay, so let's look at one like this, but a bit more difficult. So for example, we have integrate 1 over square root 240 plus 8x minus x squared dx. Similar, but more difficult to the last one. Does anyone have any ideas about what should be done first? Complete the square, yeah. So you have 240 plus 8x minus x squared. That's the same as minus x squared plus 8x plus 240, which is the same as minus x squared minus 4x minus 240, which is the same as minus... Oh, sorry, I'm doing the next step in my head. 8x minus x minus 4 squared minus 240, and then we have to do a minus 16, isn't it? So that's minus, no, I think it's minus here, yeah. Minus 256. So you get minus x minus 4 squared minus 256 is 16 squared, isn't it? Minus 16 squared. So we have our completed square here. It is minus, well, let me write it, the 16 first. 16 squared minus x minus 4 squared. So that's the first part. Okay. Can I go on to this? Continue? Yeah. So, our problem can be changed into this now. Square root 16 squared minus x minus 4 squared dx. And the substitution trick is still the same. We say let u equal x minus 4 over 16. Or if you want 16u equals x minus 4. And also, this can be written as x over 16 minus 4 over 16. And we have du dx equals 1 over 16. So 16 du equals dx. So we have this one. Is useful to us. So is this one, and so is this one. So I can go back over here. This will be 1 over square root 16 squared, and notice how x minus 4 is 16u. So this will be minus 16u squared, and dx is 16 du. Now what's nice again is we have a 16 in common at the bottom. So that's a 16 squared, 1 minus u squared. So that's 16 du over root 16 squared over root 1 minus u squared. Once again they cancel. So this you're left with again is sine inverse u, which is sine inverse x minus 4 over 16 plus c. Yes.
How did you change the 16 units to a 1 minus 2?
16u here? Is it, like, how did I get this line? What I did was, you can see there's a 16 squared and a 16 squared in both, so I just took it out. So I factored out here. Okay, can I scroll down? Yeah. Yeah, okay. So let's look at the next type of problem. This problem here looks very similar to one we had earlier. In fact, the numbers are the same even. Here it is here. The 1 over root 16 minus x squared. But there's a big difference actually here. It's not 1 over anymore. And this changes how you do it. It changes it a lot. So the way we can deal with this one is, first we have to draw a triangle. We can call this here theta. And we can call this side here 16. And we can call this side here x. And you see, if I do that, then this side here at the bottom, from Pythagoras, that would be square root 16 minus x squared. Sorry, 16 squared, of course. Yeah, sorry, I'm thinking now, this should be, let me fix that. This is 4 squared, that's what 16 is. So this here, yeah, 16 minus x squared. No, well let me draw it again. What I do is I put this number here, and then this 16 is 4 squared. That's what I'm putting here. And this will be 16...
But then you have to put x squared, not just x.
Here? No.
Yeah, but 4 squared, 4. It's just 4.
Yeah, sorry. I'm being stupid. 4, thank you. 4, yes, 4x and square root 16 minus x squared. So if you look at this triangle that you've made, you can change this problem into, well, if you look here, you can say cos theta is square root 16 minus x squared over 4. So if you bring the 4 up here, you get 4 cos theta is square root 16 minus x squared. So you can change this into 4 cos theta dx. So it looks like it's a lot easier, but the problem is, here is theta, and here is x, and we need to change this into d theta. So how can we do that? Well, if you look here, you could say sine theta is x over 4. So you could say 4 sine theta equals x. I'll write the x on the left. And that's useful because now you can say dx d theta equals 4 cos theta. So now you get dx equals 4 cos theta d theta. So that's great. dx is 4 cos theta d theta. So you could go back here and replace this with 4 cos theta bracket 4 cos theta d theta, and replacing the dx with 4 cos theta d theta. So this will be 16 cos squared theta d theta. Now we actually have seen a problem like that. We did this problem at the start. It was my first example. There's a little bit of a quicker way to do this though if we use double angles, which is what I want to show you as well. So you know that cos squared theta cos 2 theta is cos squared theta minus sine squared theta. So cos 2 theta is cos squared theta minus, and then sine squared is 1 minus cos squared theta. So cos 2 theta is, let's see, that's minus 2, cos squared theta minus 1. So finally, cos 2 theta plus 1 over 2 is cos squared theta. If I multiply both sides by, no, I won't bother doing that, I'll just leave it like that. So I can go back to my formula and put in 16 integrate cos 2 theta plus 1 over 2 d theta. That's 16 integrate a half cos 2 theta plus a half d theta. That's 16 integrate, and then the cos will become sine 2 theta over 2 plus a half theta. This is after I integrate now with a plus c. So I can clean this up a little bit. This is 16 sine 2 theta over 4 plus theta over 2 plus c, which is 4 sine 2 theta plus 8 theta plus c. Now we need to remember what theta is. So if I just go up, you can see sine theta is x over 4. Now what you can do is you can change this into 4, and then sine 2 theta, if you use the other double angle, you get 2 sine theta cos theta plus 8 theta plus c. We know what sine theta is, and we know what cos theta is from our triangle. What did I have? I had x 4 and root 16 minus x squared. So this will be 4 times 2, so that's 8. So that would be 8 sine theta, which is x over 4, and cos theta, which is root 16 minus x squared over 4, plus 8 theta. And we can get the theta here by doing sine inverse x over 4. So it's 8 sine inverse x over 4 plus c. 4 by 4 is 16. 8 over 16 is a half. So this is a half x root 16 minus x squared plus 8 sine inverse x over 4 plus c. Come on guys, turn that off. Please everybody check your phone. It stopped, right? No? Yes. Okay. Question? Yeah. No, yeah, I'll leave it there for a minute. These are the types of questions you do get in the exam, and I've seen this question in section A at least twice recently. You can take some comfort in knowing that in the exam they'll tell you to use x equals 4 sine theta. Well, I mean they have in the past at least. Can I scroll down? Ali, yes? I think we're just waiting for you, Ali, so I'm going to scroll down.
Can I just give the last one?
I suppose. Alright, I'm going to give you one to try, and then I'll do it on the board. It's similar to the one I just did. 15 plus 2x minus x squared. Integrate this. So try that for me and then I'll do it. About this one? Oh, yeah. Oh. No, it needs to be the minus there because the rule is actually squares. It's possible that that's the sign that goes there, or I made a sign that goes here.
Okay, I'm just wondering.
Although I can't really do a minus in here. Yeah, that's minus x squared. Okay, let's have a look at this. So, this is square root minus x squared minus 2x minus 15 dx, which is square root minus x minus 1 squared minus 16, because this will be x squared plus x plus, x squared minus 2x plus 1, yeah, so that's fine. So that's the same as square root 16 minus x minus 1 squared dx. So what we can do is we can make our triangle again. This side is 4, this side is x minus 1, and so this side is square root 16 minus x minus 1 squared. And this can be theta. So you can see that cos theta is the square root 16 minus x minus 1 squared over 4. So 4 cos theta is that square root there. So this is 4 cos theta dx. Now you can see that that sine theta is x minus 1 over 4. So 4 sine theta is x minus 1. So 4 sine theta plus 1 is equal to x. So dx d theta is 4 cos theta. which is perfect because then this here, that becomes 4 cos theta, 4 cos theta d theta, like before. So that's 16 cos squared theta d theta. Using the rule I showed you earlier, this is cos 2 theta minus 1 over 2 d theta, which is 8 cos 2 theta minus 1 d theta. That's the rule I gave you earlier, isn't it? Let me just quickly check. Yeah, oh no, plus 1. Should be plus 1. So that becomes, when you integrate it, 8 sine 2 theta over 2 plus theta plus the c, which I'll put in at the end. That's 4 sine 2 theta plus 8 theta. That's 4 times 2 sine theta cos theta plus 8 theta. So that's 8 sine theta cos theta plus 8 theta plus c. Now I can find the sine and the cos from my triangle. This is x minus 1, this is 4, and then this is square root 16 minus x minus 1 squared. So sine theta is x minus 1 over 4. Cos theta is square root 16 minus x minus 1 squared over 4. And theta is sine inverse x minus 1 over 4 plus c. So this will be a half x minus 1 square root 16 minus x minus 1 squared plus 8 sine inverse x minus 1 over 4 plus c. 8 sine inverse x minus 1 over 4 plus c. Joshua, you couldn't possibly be coming into class 48 minutes late, could you? Possibly? So what are you doing here? Yeah, but your next class isn't for 12 minutes. Is the next class chemistry? You have to go away for 12 minutes. Okay, you have that taken down? Yes?
How do you know how to find the size of the triangle?
Well, oh there it is actually there. We always put it like this, that we put, because there's, when you think about your triangle, if you think about Pythagoras, this side has a square root a squared plus b squared. This side is a, this side is b. If you have a minus inside of it, it can't be this side, it has to be one of the other two. Like for example, if this is c and this is x, this is square root c squared minus x squared. So straight away, because there's a minus here, I know that it must be this side or this side. And in fact, it doesn't matter which way around I draw the triangle. If I put x minus 1 here, oh yeah, and of course this would have to be the hypotenuse if there's a minus here. So if I put x minus 1 here and 16 here, or if I put, 4 here. If I put the 4 here and the x minus 1 here, both are fine. It's just that we usually choose to put the x side here. The 4 has to go here, and so the square root has to go here. So our choice is, where do we put the x? Do we put it on the opposite or do we put it on the adjacent? If you put it on the adjacent, if you put it here instead, I think the only thing that'll change in your answer is that this will become a cos inverse, and I think there might be a sign change somewhere. A plus might become a minus. But it's not a big deal which way around you put it. Just make sure you put the x on one of these sides, and the hypotenuse, which is 4, must go here. Yeah, I think if we swap the sides around, I think the only difference is this would be a cos inverse, and I think this might be a minus. Not 100% sure though. Alright, we'll leave it there, so.